There we go. All right, we're going to graph lines today.
Yay.
This should be a review for you. You ready? All right. Tell me some things that lines have. What do you know about a line?
X and Y axis.
There's an X and a Y axis, so it has, keep going with that X and Y axis deal.
So I have Y-intercept.
It has a Y-intercept. What does that mean, Darion? Yes, it crosses the Y-axis. What else?
Straight.
Here's a question. Do they all have a Y-intercept? No. What kind of lines would not have a Y-intercept?
An X-intercept line.
You're kind of, think about this. Very good. A vertical line, right? It does not have a Y-intercept, but what does it have? An X-intercept. Very good. Let me not throw the pen. Can it have both?
Yes.
Sure. It's got to have at least one. Can have both. Okay? So intercepts are places where we cross the axis, yes? Tell me something else you know about a line. It's straight. It's endless. It goes on forever. How many points does it take to make a line?
2.
2. You need at least 2 to connect to make a line. What else do you know about a line? What does it have? All slope. Oh, man. All lines have a slope. That's exactly right. I know I spoiled it. I'm sorry. Tell me, what is a slope?
Angle.
It's kind of the angle that the line is going, the steepness maybe of the line, the ratio of how fast it goes up
Rise over run.
to how fast it goes over, the rise over run. Do you remember the formula?
Y equals mx plus b.
Okay, that's the slope-intercept form of a line, and we're going to talk about that. But do you remember the formula for finding, and I've got an M here because that's what we use to represent slope. It absolutely, you're on the right track.
Y1 minus Y2.
Rise, that's right. You start with the Y's because the Y-axis is the one that rises. So it's the difference in the Y's divided by the difference in the X's. Rise over run, right? Okay, any 2 points on the line will give you that. Does that make sense to everybody? Are we knocking some cobwebs off? We remembering this from Algebra 1? All right, so just to make sure that we do understand, let's take 2 points and see if we can find the slope between those two. Okay. Darion, give me 2 points on a line. Any 2 points you want.
4, 9.
4, 9. Give me another one.
-3 and 6.
-3 and 6. Does everybody agree that if I graph these 2 points, I could use them to form a line?
Yeah.
Okay, we'll talk about that in just a minute, and we'll do an example and graph it. But let's first, if these are 2 points on a line, let's find the slope. So I'm going to let the first point be x1, y1. What do you think the second point is going to be?
X2, Y2.
Y'all are so smart. x2, y2. Okay? Now, in the initial formula I gave you, I said it was y2 minus y1 over x2 minus x1. It really doesn't matter which one you start with, as long as you start with that same one on the bottom also. So I could come back over here and I could say y1 minus y2, but I would have to say x1 minus x2 on the bottom. Does that make sense to everybody? All right. Tell me what is in the numerator here. That's the top. 6 minus 9 over
-3 minus 4.
-3 minus 4.
What would be -4?
What happens to the top here? What's 6 minus 9? -3. Over, you're exactly right, -7. And whenever I have two negatives, what happens? It becomes positive. So interpret what this means to me. What does a slope of 3 over 7 mean? It's the answer. It's the slope.
Up 3 and run 7.
It rises 3 and runs to the right 7. Right. It's a positive slope. Positive slopes always go uphill, right? But the slope tells me the steepness there. The bigger it gets, the steeper it is. So that means if I started at any particular point, I'm going to go up 1, 2, 3 and go to the right 1, 2, 3, 4, 5, 6, 7. That looks pretty good, doesn't it? Okay, so does everybody understand that? Rising and running. What happens if it's a negative slope? Like, let's say my slope was -2 over 3.
You go down to,
Do I go down and to the left?
go down to the right.
Always stay right. You're absolutely right. So this would be from any point down 2 and to the right 1, 2, 3. If you moved left, if you moved down and left, you'd end up with a positive slope. Everybody good with that? For sure? All right. Let me talk about plotting these points real quick because I know that that seems elementary, but let's make sure everyone knows how to plot a point on the coordinate plane. Let me put a grid, a graph on here for you.
Or you can do that with this.
That's
Let's put
awesome.
some, you like that?
Yeah.
Looks good, doesn't it? Sweet. I'm going to even put you some axes on here. What axis is that? The y-axis. What axis is that? The x-axis. Very good. All right. Give me another point. Anybody? Anybody give me a point.
1,
1. What's the y-coordinate?
0.
0. Remember, our ordered pairs are in the form x, y. This is x. This is y, yes?
It's 0 and 7.
Okay, we'll do that one next, remember. All right, if I am going to plot 1, 0, that means I go to +1 on the x-axis. Which way is positive?
Right.
To the right. Here's +1. And 0 is my y-coordinate. So what happens?
Stay right on line.
Absolutely. It sits right there on the axis. All right, Amaya, what point did you say? Did you forget?
6,
I'm going to make one of them. Let's do -8. 10? I don't think I can go up to 10 on here. 1, 2, 3, 4.
8.
Let's do 7. Somebody said 7. Let's do 7 because I can go up to 7. All right, -8. That means my x-coordinate is negative, right? So I'm going to start at the origin and I'm going to go left. 1, 2, 3, 4, 5, 6, 7, 8. And up 7. 1, 2, 3, 4, 5, 6. Oh, I'm running into my point. Right there. Does anybody need me to do any more? Do y'all remember how to do that?
Yeah, I used to read.
Okay.
From Algebra 1.
From Algebra 1. Good job. All right, then let's talk about some forms of lines. I want to talk about two specific types of lines first, and then we'll talk about some equations of lines that we're going to graph, okay? The first is the easiest. How do you write the equation of a vertical line?
0 and 7.
No clue.
No clue. Does anybody know?
No, listen.
You're right, it's x equals and then whatever number you want to be at, okay? I'm going to teach you a little trick. I'm going to show you a little trick that helps me remember. So vertical lines are in the form of x equals some number, okay? So if I said x equals 5, that would mean that at 1, 2, 3, 4, 5, bless you,
Thank you.
there's a vertical line, right? Now here's how I remember, because everybody always wants to mix these up. This is a cheesy little trick. Are y'all ready? See the little arrows on the end of my line going up and down, straight up and down?
Yeah.
Well, it kind of looks like what makes up the X, right? Up and down.
Gosh.
Y'all are looking at me like, oh.
I mean, really, that's true.
But that helps me remember that X equals is a vertical line pointing straight up and straight down. So if a vertical line is X equals, what do you think a horizontal line is? Good job. Y equals. And it can be any number. Let's say it was 2. Then I would be on my coordinate plane and I would go to 2 on the y-axis, straight across. Does that make sense to everybody? All right. So if I ask you to graph any horizontal or vertical line, you should be able to do that, right? Like if I say graph the line x equals 2. Can you do that? This means yes, this means no, yes. How about if I asked you to graph the line x minus 3 equals 0?
No.
Yeah, I can do that.
Could you do it?
Yes.
Yeah. X equals 3.
It's just written a different way. It's still x equals 3 because if you add the 3 to both sides. Oh, everybody goes, oh. Ah.
That's tricky, bro.
That was a little tricky. What if it was x plus 1 equals 8?
You're the one on both sides.
X equals 8.
That was the same thing.
And it doesn't matter if it's x or if it's y. What now? Add the 2 to both sides. So here's the key, guys. If you just see, I'm going to go into my 2, 3, 4, 5, 6, 7, 8, 9. These are just quick sketches for sure. But if you just see one variable and that's it, go ahead and solve it for that variable, okay? Are we good on horizontal and vertical lines?
Wait, vertical is x equals, right?
Absolutely, yeah. Vertical is x equals, horizontal is y equals. Other questions? All right. Let's do our other lines. We got 3 forms of lines we're going to talk about. First one is probably the one that you are most familiar with. What does slope-intercept look like?
Y equals mx
Absolutely. Y equals mx
plus b.
plus b. Tell me what the variables represent. What is m?
Slope
Slope. What is b?
x. Or no, not x. I think.
Y-intercept. It's where it crosses the y-axis. Yes? All right, so if I gave you an equation that was in slope-intercept form and you need to graph it, what would you probably do first? The y-intercept. That's absolutely where I would start. And then you could count the slope off from there, right? So let's do one. Maybe I should put that. Plot the y-intercept first and apply the slope. Tell me, while we're waiting on some people to copy this down, what happens at every single y-intercept on every single line all the time? What is it? Like if I have this line and I told you that the y-intercept here was 0, -2. And then I have another line here, and I told you that this was maybe 0, 3. What do these points have in common? They're both on the y-axis. Those, absolutely, Maya. Did y'all hear what she said?
Nope.
They both have 0 as their x-coordinate. Okay? So if you think about this equation, it makes sense that that's the y-intercept, because if you plug 0 in for x, this term is going to kind of go away, right? We'll talk more about that when we get to standard form. All right. Let's graph this one. Before we start, what's the y-intercept?
3.
3. What's the slope? 1/2, right? All right. I'm not going to put the grid on here. All right, so if I plot the y-intercept, I'm going to go up to what?
Up 3.
3. Now apply the slope.
To the left.
Down 1
To the right 2.
and right 2. Down 1, right 2. Rise over run, okay? When you are being exact, like in your classwork today, you'll want to get a straight edge to connect and make it look pretty. I'll give y'all a second. All right, let's do another one.
Okay.
You try this one first on your paper, and then we'll do it together. Give it a try, then we'll do it together. All right, some of you are finishing up. I'm going to just put my axis on here. All right, where'd you start? -1. Now what do you do? Up to.
To the right 3.
Good job. 1, 2, 3.
We gotta start from the wins.
I'm gonna use it down
Are you?
Yeah.
All right, any questions about that one, guys? A lot of. We have 3 forms, that's 1. The next form.
Standard.
Standard form.
This involves like that AX.
It does. It does. Shh, shh. Guys. Shh, shh, shh. Focus. Standard form. Remember what you told me about y-intercepts? What did you tell me, Trey? What did you tell me about the x-coordinates on the y-intercepts? They're always what?
0.
0. So now flip that around. What do you think about the coordinates at the x-intercepts?
Always 0.
What's always 0? The what?
Why?
The y is always 0. That's your key to this form, okay? At x-intercepts, y equals 0. At y-intercepts, though, what equals 0? X, that's right. Okay, so here I've got these coefficients in front. I've got a constant is what it equals, And I've got the x and the y on the same side with the coefficients in front, okay? So this one I'm going to use the intercepts to graph it. Is the easiest way, right? Some of you may have learned this as the cover-up method. I like to teach it to you using intercepts because that's what you're doing actually. All right, let's think about this a second. I think it's easier to show you with an example. Do we all agree that's standard form?
Yeah.
Mm-hmm. Now think about this. If I want to think about it in terms of intercepts, the x-intercept is when you told me y equals 0, right?
Yeah.
So if I look at this equation and I put a 0 in for y,
Cancels out.
right, well anything times 0 is 0, so I end up with 2x
Equals 12. Divided by 2 on both sides.
divided by 2. That's what we were doing yesterday.
X equals 6.
So the x-intercept, or where it crosses the x-axis, is 6. Now flip that thinking around. What about the y-intercept?
X
You
would
do
equal
it for the
0.
X.
Absolutely. Y'all are so smart. X would be 0. Look at you go.
Well, super smart.
Wait, I was right?
You're right. Yeah. So this term kind of goes away, and you get 3y equals 12. So y is 4. Do you see why somebody might call it the cover-up method? Because if you're looking for the x-axis, you can kind of cover up that and set it equal. And if you're looking for the y-intercept, you could cover up that piece and set that equal. But really what you're finding are the intercepts. So now that's not enough. I need to graph it. Now don't mess up. This is not a 0.64. These are intercepts. Intercepts are places where it what?
So there's going to be 2 lines.
Crosses. Absolutely.
That's where it's going to
Super smart.
Y is 4. 1, 2, 3, 4. X is 6. 1, 2, 3, 4, 5, 6. There we go. Does that make sense to everybody? Graphing in standard form. Want to do one more?
Nope. We got it.
Come on now.
Yeah.
Does everybody have it?
Yeah.
Do one more. Let's do one more. It never hurts to do one more. Oh my goodness. We only have one form left, and it's my favorite form.
What is it?
Point slope.
Hey.
It's the most useful form, I think. All right. Let's do one more. Yes, try this one on your own, and then we'll talk about it.
No, Trey, you just bust out a number.
All right, let's do this. A lot of you have already gotten it. If I do the x-intercept, which is what I hear everybody talking about, then 1/2 times x minus, remember this is going to go to 0. So what happens when I need to get rid of a fraction like that? Reciprocal. What's the reciprocal of 1/2? 2. So x is 12.
Oh, I kept the denominator 2.
Oh. Let's look at the y-intercept. So that's where the x term is going to 0.
6 divided 3.
Don't forget to keep the sign with it. That will mess you up. So I got to divide by -3. That would be -2. So when I graph it,
Oh, negative.
You can't gain what?
all right, -2 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Trey, what you talking about?
Explain this to her.
Oh, okay. Go ahead. Yes or no?
Yes.
All right, y'all ready for the last form?
We can't, well, let me just for the
Right. Yes. No, go ahead. You got a question? Oh, go. It's okay. Grab the pass. All right. You got it? Caroline, you good? All right. Thank you, Trey. All right. Point slope form is the easiest form to write the equations. It's a little bit more difficult to graph from that form, but it's not difficult at all. All right. Let me just give you the form first. How many of you have seen point slope before? Good.
This is weird. We get a formula sheet for
We
this, right?
all did this in algebra 1.
I'm so
I did it
glad.
this weird.
So are y'all bored? You already know how to do all this?
It's just like,
It's needed.
Yeah, it's good to refresh, I think. Especially some of you, it's been a long time since you had Algebra 1. All right. So we all know what M means, right? Slope. And since it's called point slope, it also contains a point, okay? Any point on the line you can use. That's why it's so convenient for writing an equation of a line. Any point on there is x1, y1. Ooh. So really, if you need to graph it, you can use the coordinates x1, y1, and then you can apply the slope just like you did in slope-intercept form, right? All right. The thing to be careful of in this form is that these signs have to be minus, okay? So if you have y, I'm not writing. All right, so if I had y minus 2,
won't go away.
I'm showing you, we're fixing to graph, but I just want to show you how the signs work here. What is the slope in that equation? 3. What is a point on that line? And be careful before you answer that. A point. A point has 2 parts, an x. All right, so I heard 1, -2. But I'm going to say it's -1,
-1.
+2.
That is.
Okay. Look back up at how the equation has to be written. It has to have a minus sign there. Okay. If there's a plus sign, you've got to change the sign of the number. So that's where it's going to be confusing. All right. So think opposite signs in this whenever you're looking at it. All right, for your point. No, you're not. You're going to be good. Let's graph one. See what happens. In fact, let's graph that one. Well, no, let's do a different one. Y plus 1 equals -1/2. All right, try to graph that one. I'm sorry that the announcements are on, but we'll just go ahead and work this one real quick. What's the slope? What's the point on the graph? 2. Remember, change the signs. Start with this point. Good job.
Oh, this is dope. I get it.
What do you mean change?
All right, let's apply the slope, guys. Down 1 over 2.